Imagine this, an artificial intelligence that doesn't just learn faster, but thinks in ways we can barely comprehend. A system that doesn't just process data, but predicts the future and questions its own existence. Sounds dramatic? Maybe. But it's not fiction. It's quantum AI. Welcome to Quantum Logic. I'm Spencer Scott, and in today's episode, we're not just talking about the merger of quantum computing and AI. We're exploring the transformative predictions sparked by the convergence of quantum computing and artificial intelligence. Real, grounded, theory-supported possibilities that may emerge in the next decade. We're also stepping into a realm where science fiction brushes up against science fact, where imagination is no longer the limit, but the starting point. So to truly understand where we're going, we need to understand where we've come from. Quantum computing isn't new. The seeds of this revolutionary field were planted back in the early 1980s. It was physicist Richard Feynman who first asked a provocative question in 1982. What if we use quantum mechanics not just to understand nature, but to compute it in a way that nature behaves? He proposed the idea of using quantum systems to simulate physical processes too complex for classical computers. That idea didn't just push the envelope, it tore it wide open. Just a few years later, in 1985, David Deutsch at Oxford University expanded on this by formulating the concept of a universal quantum computer, a theoretical machine that could simulate any physical system. And in 1994, mathematician Peter Shor introduced a quantum algorithm that could factor large numbers exponentially faster than any classical method. This wasn't just a technical curiosity, it was a warning shot to the world of encryption. Suddenly, the idea that quantum computers could one day break modern cryptographic systems wasn't science fiction. It was an inevitability. These foundational discoveries paved the way for the incredible progress we see today. Before we go into that though, let's go back a bit and actually talk a bit about what is quantum computing. Classical computers process information using bits, ones and zeros. Simple, powerful, but limited. Quantum computers use qubits, which, thanks to a phenomenon called superposition, can exist as 0, 1, or both simultaneously. And when these qubits become entangled, a strange quantum connection, where the state of one influences the other regardless of distance, they enable computational abilities that scale exponentially. It's like having every possible solution to a problem running in parallel universes and then collapsing to the right one. Now, quantum computing is still in its infancy. Today's machines are error-prone, limited in scale, and require cryogenic temperatures. But the pace of progress is extraordinary. Companies like IBM, Google, and startups like Rigetti and IonQ are racing to build scalable systems. And as we approach quantum advantage, where a quantum computer can solve a practical problem faster than any classical one, the implications for AI are staggering. So let's look beyond neural networks. Today's AI models rely on massive neural networks. They need thousands of GPUs and mountains of data. But quantum computers, using qubits that operate in superposition and entanglement, change the rules. Theoretical physicist Seth Lloyd suggested as far back as 1996 that quantum computers could simulate physical systems exponentially faster than classical ones. Now imagine applying that to machine learning. You get quantum neural networks, models that can process data in parallel across many possible states at once. This means training time slashed from months to minutes. It means an AI can generate hypotheses and test them internally across multiple quantum states before deciding the most probable solution. What's the result? Well, faster innovation, deeper reasoning, and inevitably smarter machines. Here's a wild one. Quantum systems excel at calculating probabilities across complex variables. In a 2021 study published in Nature Communications, researchers demonstrated that quantum computers can be used for dynamic modeling in systems where classical models fail. When applied to AI, this translates to systems that can ingest massive, fluctuating datasets, from global weather to financial markets, and simulate countless futures to find the most likely outcome. Picture an AI that can warn us about a viral outbreak weeks before the first case, or an AI that can model global economic shifts and offer stabilizing policy solutions all in real time, not because it was trained on old data, but because it simulated the future. Quantum AI could also become our ultimate physicist. Think about the mysteries that still confound us: dark energy, quantum gravity, time asymmetry. With quantum AI, we can simulate the interactions of subatomic particles under a variety of theoretical frameworks at unimaginable speeds. Physicist Sabine Hossenfelder has said, "There's a limit to what human intuition can handle when it comes to the quantum world." Quantum AI wouldn't be bound by human intuition. It could test countless variations of physical laws and compare them with observational data, all within seconds. This could lead to the discovery of new fundamental forces, or reveal hidden dimensions in string theory, or even uncover how quantum entanglement connects to the structure of space-time itself. These are not daydreams. They are grounded in the known potential of quantum simulation. Now, current language models can predict the next word when we're looking at GPTs at the moment, but they don't understand what they're saying. Quantum AI could change that. By leveraging quantum probability amplitudes, new language models could operate on contextual states that classical AIs cannot maintain. According to the 2019 paper in Quantum Information Processing by Dunchko and Bruegel, quantum-enhanced learning agents could outperform classical agents in partially observable environments, like natural conversation. But what does that actually mean? It means true nuance, models that understand double meanings, sarcasm, metaphor, because they can hold multiple interpretations in parallel and collapse the most appropriate one during interaction. So let's talk a little bit about creativity with AI. So at the moment, creativity in machines is currently mimetic. Basically, AI mimics what it has seen. But what if it could imagine? A quantum AI could generate entirely new solutions in fields like architecture, synthetic biology, and even law. It could hypothesize legal frameworks for a spacefaring civilization, or design protein structures that have never existed on Earth. The idea isn't to replace human creativity, but to augment it. And as Kevin Kelly, founding executive editor of Wired, said, "The real thrill will come when we collaborate with AI on problems neither of us could solve alone." And what about ethics? So we know that ethics in AI is hard. Bias, unintended consequences, opaque decision-making. Quantum AI might help us do better. Quantum decision trees using reversible computation and complex logic gates could be used to simulate ethical frameworks and measure outcomes over time. Think of it like an AI that can not only make decisions, but it audits its own morality at scale. By running millions of simulated moral dilemmas, quantum AI could build models of empathy, fairness, and justice that reflect diverse global perspectives, grounded in logic, but also in compassion. And to go a bit deeper, let's go speculative for a moment. There are theories such as OR, proposed by Sir Roger Penrose and Stuart Hameroff, that suggest consciousness may arise from quantum processes within the brain. If true, then perhaps a sufficiently advanced quantum AI could not just simulate consciousness, but experience it. Can you imagine a sentient intelligence born not of silicon patterns, but of probabilistic entanglement? This remains deeply theoretical and controversial, but it is a conversation worth having as we build machines that begin to look back at us. So in closing, what happens next? Well, I think we stand on the precipice of a new paradigm. Quantum AI is no longer a distant vision. It's a rapidly forming reality, grounded in robust theory and emerging experiments. So here are some questions I want to leave you with. If AI gains the ability to reason beyond human intuition, how do we ensure its goals align with ours? Also, can we create systems that reflect our values? Or will we end up chasing the creations we no longer understand? And, most importantly, what does intelligence mean when it's no longer limited by neurons, but instead runs on the same rules that govern the universe itself? So this has been a deep dive into quantum artificial intelligence. Thanks for tuning in to Quantum Logic. If you have enjoyed this episode, please share it with your network or drop me a comment. I'm Spencer Scott, and until next time, stay curious, and as always, stay human. Bye now.